Welcome to the Storage Developer Conference EMEA in 2022. And my topic today is what is a Symlink race and how Samba deals with them right now, what the problems with this approach are, and how we are going to deal with it in the near future. So what is a Symlink race? Let's do a quick search in the CVE database for Symlink race. And what you can see here is that just this simple search as of a few days ago showed there are 1,354 records that just contain the word Symlink. And the topmost here is a problem in the Trend Micro antivirus for Macintosh, which could allow an attacker to create a specially crafted file and so on, leading to a privilege escalation, which means that a non-privileged user like you and me will be able to utilize privilege like root access. They are going to be administrator on my machine. There are 1,354 of these, and there must be something going on. But what exactly is going on? And let me explain this with a little example. So imagine I want to publish photos of my cat to my blog. How do I do this typically? I use a graphical directory browser like the Windows Explorer, or in this case, the Linux Nautilus. I find my cat photos, I look at the full path that I have here, I copy this file path into the browser, and then I press upload. Let's look at my directory hierarchy in more technical terms and how that looks like. I have my photos folder where my pets are. I have a dog, I have a cat, I have 2 photos of my cat, but I also have had a case with my insurance, and my car recently had an accident. And yeah, this is obviously not what I want to publish to my blog. I want to publish the file photos pets cat 01.jpg to my blog. This is my photo, the cat playing with another animal. How is this Symlink race now happening? I publish my cat photo in 3 different steps. I browse my directory hierarchy, then I copy the file path into my Firefox or Chrome or whatever, and then a few seconds later I press upload. And in these few seconds, an attacker could just launch an attack on my photos pets cat01.jpg browser. What the attacker does is it replaces the 01.jpg file with a symbolic link to the latest communication with my insurance. And what you see here is the Linux command that could be used to do this. They link the 02 from the car folder onto what 01, onto the 01 of my cat. And after this attack has happened, my directory hierarchy looks a bit different. It looks like this. The 01.jpg, the photo of the cat playing with the other animal, has been replaced with a symbolic link, which just crosses directory hierarchies, everything, to my photos that I had with from communication with my car insurance. And instead of my cat photo, what gets published is this now. Oops, this is kind of a bad accident. I mean, obviously it's not my accident. It's a picture from Wikipedia or somewhere else with a decent license. But the point is, this could have been your password docx file with all your Amazon or Google Mail or whatever credentials. This is just a bit embarrassing, but your passwords file could be completely fatal. And this is what could have happened after this Symlink race attack has happened. Linux and POSIX have a protection against this kind of attack. What you can do is you can add the ONoFollow flag to the open function, which is the C function that Linux uses to open a file. This ensures that 01.jpg is not a symbolic link. Looking at the man page, you see that if the trailing component, i.e. the base name, in our case it's just 01.jpg, of path name is a symbolic link, then the open fails with the error e loop. When using ONoFollow, the upload function will get an error. And this is exactly the case that the attacker has created here. The last component of my complete path, photos pets cat 01.jpg, is a symbolic link. And if my browser then uploads this file, attempts to upload this file, it will detect it's a symbolic link and gets an error. However, if we read on in the main page, we see that symbolic links in earlier components of the path name will still be followed. What is this? We have the same scenario. We paste photos pets cat to 01.jpg into the browser. But now the attacker does a little different thing. He takes two steps. First, he replaces or renames what used to be the cat subdirectory into cat.old, where my photos still are. Then he replaces the cat directory with a symbolic link to the car directory. And that's also something that symbolic links can do. They can replace directories somewhere within a path. So what now happens is, if we follow photos pets cat and want to publish 01.jpg with the intention to publish our 01 from the cat subdirectory, what instead we do is we publish 01 from the car subdirectory. You can see this here. Photos insurance car 01. And this is a different accident that I recently had, or obviously I didn't, but this also could have been your passwords file. And yeah, equally bad, but it's a different attack. And this attack is much harder to overcome than just to add the ONoFollow flag to the open call. How do we do this? There's 4 steps that we need to take, and that Samba right now also takes. We first do a change dir into the cat subdirectory. What does it mean? You can, as a Samba process, as the Samba server side, you can just fully fix yourself, and I indicate this by this little icon of a man standing here, of a person standing here, that the Samba process just changes into this directory and cannot be removed again anymore from by the Linux kernel. And what I then do is first step, as I said, I change into this directory. Then I check I'm really in photos pets cat, and this is the important piece. And this assurance by the Linux kernel, after I've done this check, this cannot be violated anymore because I'm sitting in this directory. And I will show you what happens when the attacker now plants his attack. I'm sitting in this directory, and now what I do is I open this 01.jpg with ONoFollow, and I'm safe. Let's look at what happens when the attacker places the attack that I described a few slides ago. The attacker has replaced the cat subdirectory with a symbolic link to my car subdirectory, but I am moved together with the directory. I still am sitting in the directory. The directory doesn't change. It's only the name of the directory that changes. So if we open 01.jpg with ONoFollow, it still references the correct file. The problem here is that opening files becomes expensive due to the 4 steps. Change into the target directory, check we're there, open the file, and then change back. Linux also has ways to overcome this. By the way, this is also in many of the commercial Unixes. This is not Linux only. The way to do this is we can not change directories to this cat subdirectory. What instead we do is We do these 4 expensive steps just once and reference this directory with a number. We make the kernel open this directory as such and give us a number, and obviously this is number 42 here, and this will forever be the reference to the correct cat directory, even if it's renamed, even if it's moved, even if the path is being messed with a symbolic link somewhere in between. And now what we can do is we can only do this once, and we can cache references to our target directory, and then we can do the cheap open add call to 01, referencing the directory as the first argument. And that's the way to go. So summing up, Symlink races from 30,000 feet. Path names in POSIX are prone to input validation problems. Symbolic races are a time of check, time of use, or short TOC2 problem. We check we are in the right directory, or we check a path, we look at path, photos, pets, cat, whatever, file name, and then we make use of this after we did check this is the correct file, but something has in between changed. Sanitizing these paths is tedious, so nobody does it. And the current status in Samba 4.16 is that we are safe, at least we believe to be safe, because all places where we do path name, path-based operations, we do these expensive change dir, check open, change dir back approach. But what we want to do is we want to pass these directory handles, what I referenced as the number 42 a slide ago. We want to reference this everywhere. The Linux kernel has work ongoing to make things easier. And I will show you this in a few minutes, that this open at 2 syscall really speeds up things. And there's also a mount option to mount file systems, completely disallowing symlinks. So if you don't really need symlinks, and symlinks are the source of this problem, if you don't really need them, you can completely disallow them and not have the kernel follow them at all. So what's the current status in Samba 4.16? OEMs have complained to us that Samba 4.15 even, because this is where all the changes have gone in, is slower than 4.12, in particular for benchmarks like spec SFS, which is an important benchmark for evaluating the performance of a file server based on Samba. And this software built spec SFS test does a lot of stat opens, which means that the client just asks for file metadata like timestamps or file size. And why is Samba slower? The sheer number of syscalls to open a file that Samba needs to do to just open a file is a lot more in 4.16 than it used to be in 4.12. And I show this with the example I S-traced one of our server processes. And on SMB client, I just did a simple open, single call open this file abcdefg x.txt. And what I ended up with in 4.12 is 30 syscalls, which is a lot, but it can get worse. 4.16 has 55 syscalls. And for the 4.17, got back to which is master, which is not released yet, got back to 43 lines. And how did we do this? We removed one of these change dir, check open, change dir back steps by just referencing in one place, referencing the directory this directory G that you can see above, referencing this with the 42, and use this reference 42 in more places. And we have work ongoing to remove many more of these calls. And we want to replace these expensive checks, change dir, check open, change dir back, with many more of these open at referencing calls. For example, if you look at deleting a directory, there are 3 steps right now. We need to open a file. This means that we have to have the path name being checked with these 4 steps. Then we will open the parent directory and check is deleting a child, which is a file in the containing directory, if that's permitted. Then we set the delete on close flag. I mean, everybody having looked at Windows traces knows what delete on close is. It's the Windows way to tell the server, hey, delete this file, please. But what you need to do there is we need to check for the empty directory, for whether the directory is empty to give the proper error message. And this means yet another of these 4 expensive steps. Then we need to close the file, which then, or close the directory, sorry, which then does yet another set of these 4 steps to be able to use the unlink add call, which references a directory properly and is not prone to a Symlink attack itself. In each of these steps, there's one call to this non-white link open function that Samba uses. This is the Samba description of the Samba function call of these 4 expensive steps. How do we speed this up properly? And for this, to show you the possibilities that Linux gives us these days, I have prepared 3 little test programs that really are the core of what we do to open a file. The test change dir is do what we do today in most of the cases, which means get current working directory, check where we are, then change dir into the target directory, and verify that we are actually in the current working directory. If that's within the share, we are not being attacked under a Symlink attack. Then we do an open of the file with on follow, and then we change dir back. And I have a little benchmark to show that. I'm running this test change dir, and what it will print from the second line ongoing is the number of these steps that I've described per second. So what this means is that we get roughly 45,000 of these steps per second on this little machine here. And we will compare this with the other possibilities that we have. The next test program is a little different approach. What we do is we single step through a set of path components. And let me show you the source for the test change dir program to explain what this means. So this test change dir program wants to open subdir slash subdir slash subdir and so on. You can see what it wants to open. Then we do the change dir, subdir, 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 and so on. Imagine this is ABC, X, or pets, cat, 01 or whatever. And we change dir, we do this real path call, we open the directory, we open a file inside this directory, and this is the expensive one. What we now do is we look at the test open at variant, and this is a slightly different approach. We don't go to subdir, subdir, subdir. What we instead do is we do this step by step. We do a change dir into a we open subdir. We open subdir with owner follow. We won't want symlinks. And we pass this reference to the subdirectory into the next round. So we do a log step of open subdir, check this, open subdir, close the just referenced directory. So we do a log step and get a safe way to our target directory subdir, subdir, subdir. Let's look at what this gives in performance. Test open at. And this is same order of magnitude. It's a bit faster, but the details may vary a bit. But on this laptop, in this situation here, it's a bit faster. But now let's look at what the Linux kernel has planned for us. I just listed that the Linux kernel has openat2 resolve no symlinks, which means it can open a file and it guarantees that within this path to symlink, subdir, or to photos, paths, cat01, there are no symlinks whatsoever. So we are safe from any kind of symlink attack with this TOC2 race, where any symlink in the middle can happen. So, and this is what this test openat2 program does. Let's look at that. This just does a direct Linux syscall, and this is not in the libc yet. This does a direct syscall to subdir, giving it the flag, no, I don't want symlinks at all. Please make sure that none of this subdir is a symlink at all. So I'm safe. And let's see how this performs. And what you can see, this is an order of magnitude better. And the main reason for this being that the sheer number of syscalls that we are using in these two other alternatives, in the test change dir, what we do now, in the test openat, what we are planning to do soon, and then on Linux platforms that have the openat2 call, yeah, this is so much cheaper because we just have a single system call and the Linux kernel does all the hard work for us. So, and this is what we are planning to do in the future. And if there are any questions, feel free to contact me on these channels. Thanks for your attention.